Now this illustration illustrates making a tap to supply a disconnect, controller, and motor. Now we can't use, in this case, 230.81. We can't use 240.21b. We can't use 240.21c. We cannot use 240.92c and e. We have to go into the motor section, find our section that deals with this tap, and it's 430.82. Now you must go to 430.28. You have to make sure that you go to this section so that you can make the kind of tap that is needed to supply the disconnect, and then the disconnect take care of the controller and motor, allowing the motor to start and run, and so forth. Now notice, if you're applying the note 1 and 2, if you please will review that with me. Note 1 states the overcurrent protection device on the line side shall not exceed 10 times the ampacity of the conductor. Note 2 states use 430.28.2, an exception when using the 25-foot or 100-foot tap roof or motor circuits. Now, applying the information that you see in the note, we have a motor that's 40 horsepower, 3-phase, 460 volt, design B. The type of motors are listed in table 430.52, squirrel cage induction, synchronous, wound rotor, DC motors. They're listed there. Now the controller is sized by 430.83, A1 exact. The disconnect is located 50 foot or less from the motor in accordance with 430.102 and controller. The 10-foot tap is made by 240.21F, which allows the tap, but we go to 430.28 item 1 to make this tap. Now notice the minimum size tap is listed as number 6, as you see to the left, right at the top of the disconnect and below the tap junction box can. Quick Count 1 shows that 10 times 65 amp is 650. The overcurrent device ahead of this tap is 65 amp. So we know that, the conductor number 6 is 65 amps. The overcurrent device is 600 amps. So we are below the 650, or you could divide 600 by 10. You come up with 60 amp, and you see the number 6, good for 65, is okay from the junction box to the disconnect. Then usually non-time delay fuses are used in the disconnect, which will hold 5 times their rating, allowing that motor to start and run based upon its code letter and design letter that we would find for starting purposes in table 430.251b, as referred to that table from 430.79 that you would look at there, 430.9 that we would look at. Now, reviewing that information, then note 2 has been complied with. It's either 10 into the overcurrent device or 10 times the tap conductors. That's all note Calc 2 is telling us. So from the disconnect now to the motor, 220.50 of the code would refer you to 430.22 of the code, and you take 125% of the full load current of the motor, not the nameplate now. You would go to 430.6A1, and it would refer you to table 430.250 for a 3-phase motor. And then the design B is simply telling you how the manufacturer is going to manufacture that motor. So the type of device that you select is in table 430.52. So it'd be time delay fuses in most cases. So we know we can set those up to 175% minimum, and then use any size that we need to allow the motor to start and run. So you get into that more when you get into chapter 18 and review the information there for sizing the overcurrent device and the disconnect and the conductors to the motor. So you have a tap rule from the junction box to the motor, and then, or say from the junction box to the disconnect, then the disconnect sizing conductors to the controller and motor, then you would size those as we have just stated and see what your ratio comes out. So this illustration is giving you the information that we would need to design this tap, and the next illustration will illustrate that. Now, before we move on, all terminals you see in the illustration are 75 degrees C, meaning when we select our conductor from table 310.16, we can use the 75 degree column.